Some forms of weaponry are available exclusively to superpowers. And this not only refers to nuclear, cruise, or ballistic missiles, but also to aircraft. Sixth-generation fighters can lay claim to being the most technologically advanced of all military weaponry. Building such an aircraft is an incredibly difficult task. It's much more difficult than building an aircraft carrier. That is why the UK and Japan have combined forces and are now jointly developing a sixth-generation fighter that will in the future replace the Eurofighter Typhoon and the Swedish Gripen. What has been the result of this British-Japanese alliance? You're about to find out. The UK is currently working on an advanced fighter. The project is known as BAE Systems Tempest. In addition to the UK Department of Defence and the company BAE Systems, Rolls-Royce, Leonardo SPA, MBDA, and Saab have also been involved in the Tempest project since its beginning. Several European nations have also joined Team Tempest. In total, more than 600 organizations are involved in the program, including small and medium-sized enterprises and research organizations. And now, Japan has just joined the team. In the land of the rising sun, they have also been at work on a next-generation fighter. Program FX began back in 2010. The demonstrator of its technology is the Mitsubishi X2 Shinshin, with only a single copy having been built. However, it is not worth paying attention to X2's prototype's outer appearance. It is just a flying test unit for trialing out new technologies. This is now the fourth Japanese FX program in the country's history. It was the stance of the US military which forced the Japanese to begin their own research. The states do not want to share their technology, nor give Japan a license to build F-35s. Japan, in turn, does not want to simply purchase its planes so as to avoid losing its manufacturing. At some stage, work on these fighters stalled, both in Britain and in Japan. However, the land of the rising sun were able to get a little further ahead. The Japanese have managed to find a perfect formula for their power plant. We're talking here about the XF9 engine. The prototype has already been bench tested. The engine is quite compact, an important feature for a stealth aircraft. However, Japanese engineers also succeeded in giving the unit increased traction and the ability to change the thrust vector by 20 degrees. Recall that even the Typhoon in its usual configuration does not have a variable thrust vector. Tests showed that the Japanese XF9 engine is 30% more powerful than the General Electric F110 engine, which is equipped in the F-15 and F-16. The afterburner thrust of the XF9 prototype exceeds 33,000 pounds of force. At this stage of development, the power of the Japanese unit is comparable to that of the Pratt & Whitney F119 engine, equipped to the F-22 Raptor. During testing, the engineers avoided spinning the engine to its limit in order to preserve the prototype for further testing. 33,000 pounds of force is notably more than the EJ200 engine that powers the Eurofighter Typhoon. Recall that its afterburner figure is only 20,200 pounds of force. That is, even the prototype of the new Japanese engine outperforms some of the existing modern analogs. After final refinements are made, the XF9 unit will certainly be able to produce 15 to 20% more thrust than during prototype testing. If the XF9 adds more power, it will be comparable to the power of the Pratt & Whitney F135 that powers the Lightning II. Recall that the thrust of the F-35 engine reaches 40,000 pounds. However did the Japanese manage to create such an outstanding unit? Japanese engineers have managed to raise the temperature at the turbine inlet to 3,300 degrees Fahrenheit. In the future, the temperature will be raised even higher. An increase in temperature increases the output of the engine. The higher the temperature, the higher the power. To raise the temperature without devastating consequences, Japanese engineers have created a new ceramic-based composite material. The turbine casing is made with this material, and it is this casing that experiences the greatest thermal stress. The old nickel-based alloy could withstand no more than 2,500 degrees Fahrenheit. The limitation posed by temperature conditions has long been a serious obstacle to increasing engine power. In addition to their new material, the Japanese introduced a new manufacturing method in the production of individual turbine components. We're talking about 3D printing technology. Turbine parts for the prototype were 3D printed. It would seem that 3D printing is no longer astonishing to anyone. However, this was a risky design choice, as no one had previously used 3D printing technology on such critical, stress-bearing units. But the gamble paid off. Thanks to the accuracy of its execution, 3D printing increases the reliability of the engine. 3D printing technology will also ensure reductions to the production cost of the XF-9 going forward. Obviously, a fighter with an XF-9 engine automatically falls into the category of super-fast and super-maneuverable fighters. Speed and high maneuverability are two of the mandatory attributes of a sixth-generation fighter, along with stealth. Following the success of the Japanese, Great Britain offered to cooperate. Rolls-Royce also joined in on the development of the XF-9. The British Ministry of Defence immediately allocated £230 million for the creation of a test unit. Nothing except for technology and brainpower are required of Japan. Britain is footing the bill. This generosity and sense of urgency from the British is easy to explain. The fact is that not all has been going smoothly for Team Tempest in creating its sixth-generation fighter. The project development is far behind schedule, and there has been no suitable engine. True, unlike Japan, Team Tempest already has a conceptual design and vision for its new fighter. The British, as it turns out, also have their own know-how. If the experience of Team Tempest and the Japanese engineers are combined, then the world is surely set to witness a completely unique fighter. Its specifications might even be the envy of the USA. The design of the Tempest fighter is based on a modular scheme. This is in line with new strategies, in which the role played by fighter aircraft is ever-growing. The modular scheme allows the configuration of the aircraft to be adapted to any specific military mission. In addition, the modules are easy to switch out. This capability greatly simplifies and reduces the cost of maintenance, as well as making possible the modernization of the fighter throughout its service life. Appearance-wise, the Tempest does not resemble either the F-35 or the Eurofighter. The sixth-generation British fighter is being created according to the tailless aerodynamic design. The aircraft will receive two keels deflected to the sides. This configuration improves the stealth performance of the fighter. It is planned for two engines to be installed. That is where the compact nature of the XF-9 will come in handy. Two XF-9 engines turn the Tempest into an outstanding fighter. The Tempest can be flown both under the control of its crew and in unmanned mode. This is already a traditional characteristic for sixth-generation fighters. The aircraft will be able to integrate into the Link 16 combat system. We are referring to a data exchange network between tactical command, aircraft, ships, and ground units. Tactical networks like Link 16 are likely to be a key advantage in any war of the future. In combat, such an ecosystem acts as follows. Detection and capture of a target are carried out by one member of the network. Then any other can then carry out an attack. Artificial intelligence helps to select which member actually carries out the attack by analyzing the combat situation in real time and determining the type of target as well as the options available for its destruction. The types of ammunition of each network member, the distance between units and targets, and even the ability to avoid return fire are all taken into account. Artificial intelligence operates dozens of times faster and more efficiently than any person can, be it a pilot, operator, or commander of a combat operation. It is still unknown whether the British will create their own combat ecosystem or will take the United States Link 16 as their basis. At the moment, it seems that NATO members and partners are striving for unification, so the Link 16 network looks to be the most likely option. The Tempest will receive a system of sensors, the accuracy of which will be 4 times higher than existing analogs. The fighter will be able to perform the function of an air control center and oversee the course of a combat operation. Currently, BAE Systems is developing a system for controlling a swarm of drones using AI. Given the modularity of the design, the armament of the Tempest will also be able to change depending on the mission. However, the main instrument of retaliation, most likely, will be a weapon of directed energy. A promising sixth-generation fighter is likely to receive a laser and be able to withstand Russia's hypersonic missiles. Recall that today, no country in the world has a reliable countermeasure to hypersonic missiles. For its laser gun, a Japanese 180-kilowatt starter generator, which was also developed as part of the Japanese FX program, could come in handy. The Japanese had a success in this area too. With a 180 kilowatt generator, the Tempest can be armed with an energy cannon or a directional combat laser. Such combat systems disable the enemy's onboard electronics. A single impact is enough to turn a fighter or rocket into an uncontrollable object. In light of the emerging alliance between Great Britain and Japan, the Land of the Rising Sun is likely to abandon design on its own 6th-generation fighter and rely on the Tempest. If the UK-Japan collaboration proves successful, the consortium of Germany, France, and Spain may also abandon their developments. As is well known, they are also working on a 6th-generation fighter, the NGF. We will be following closely developments in all of these projects. The world just gets more and more interesting.